All right, welcome. We're going to do an example of how to make a function continuous. And remember, continuity is detected by the fact that the limit as x goes to a of f of x is just plugging in x equals to a. All right, so our example here is to find the constant c so that the function f is continuous, where f is x squared plus c when x is less than or equal to 1, and it's 4x when x is bigger than 1. Now, if you stay away from 1, then you're either, if you're less than 1, then you're just x squared plus c, and that's continuous because x squared is continuous. And if you're bigger than 1, then 4x is a continuous function, so it's continuous there. So the only place that you need continuity is at x equals to 1. Everywhere else, the functions you already know are continuous, but when you're putting them together, then this is a new, different type of function, and you need to get continuity there. So you have to have the limit as x goes to 1 of f of x, and it's supposed to be f at 1, okay? Now, f at 1, you know by the definition here that f at 1 is just, you plug in 1 squared plus c. Okay, so it's 1 plus c. So we need this limit of as x goes to 1 of f of x to be 1 plus c. Now, when we calculate this limit, it's different on the left and the right. So on the left, the limit as x goes to 1 from the left side, well, that'll just be the limit as x goes to 1 from the left. And on the left side, it's the function x squared plus c. So that's continuous there on the left. So when you take the limit, you can just plug in, and you get 1 squared plus c. And so that matches already. So that part is done. And that's no surprise, because on the left side, it's x squared plus c, and that's what we were using. So the tricky part, or the new part, is when we approach x from the right-hand side. Here, when we're going from the right-hand side, whenever x is bigger than 1, then the function is 4x, because that's what the definition says up there. So 4x is continuous, so the limit will be 4 times 1, which is 4. And I need this to match there as well. And that doesn't match unless I pick c just right. So pick c so that 1 plus c is 4. And again, it's because I have to have this guy matching this guy. So if you solve here, this will tell you that c has to be 3. So if you pick c equals to 3, then it's a nice continuous function. If you cared about the picture, you have a quadratic moved up by 3. So it's shifted up by height 3. It's quadratic for a while. And then it switches to, at time 1, to a line of slope 4. So that's the shape, though you don't really need to know the shape to get the answer. All right, that's it. Ciao.